Hi guys, I made some lab upgrades and I got a new oscilloscope. This is the one in the background here, a Regal MSO5354, 350 megahertz 4-channel oscilloscope, but it also has a 16-channel logic analyzer, and it has two function generators to generate waveforms. The one on the screen you see there is actually coming from the function generator. It's a 100 kilohertz sine wave. And as I said, the changes that I've made is mostly to do with the cameras. And if I take this little webcam here and rearrange it, you'll see I've got a little camera here. That's actually the one that's aiming at the oscilloscope. And then I've got this new camera here at the top, which both of them have zoom lenses, but the one at the top is a better quality one, and it allows me to make hopefully some better videos. So this is the camera that's at the top. So what I've got is I've connected up. This is my PC here. I've got the two cameras. In fact, there is a third camera as well, which is that Brio webcam, but I don't use that for recording videos because it is a bit annoying. The autofocus, has a mind of its own, and so I don't tend to use it normally, although occasionally I might, I don't know. And I have a couple of monitors here, HDMI 1, HDMI 2. The second monitor I use when I'm using OBS Studio, so that I actually run my applications on there, so you don't get that horrible OBS Studio thing where you see your screen repeated infinite number of times. And I have the HDMI 1 output that actually goes to I've got a HP monitor here, which is actually mounted on the wall here next to my desk, and it's going through a 5-input electronic HDMI switch, which has a remote control, so I can actually, it is actually this one here, I can actually select straight HDMI from my oscilloscope and so on, and from the microscope in the background there, or it goes through the PC. And if it goes through the PC, it actually comes out, if I have HDMI input, I have yet another switch here, and I got an oscilloscope and a microscope and an auxiliary one, which I can occasionally, if I have some other things that I can plug into there that has a HDMI output. And I then have this switch over here, so I can switch to the microscope, the oscilloscope, and the auxiliary. There's also a 5-input electronic HDMI switch, which is then connected to this AverMedia Plus 2, which is a video capture device, which then presents its output through the USB channel to the PC, which means that OBS Studio can actually capture the HDMI inputs and so on. So that is the connection that I have. You can kind of see the arrangement over here. There's the AverMedia 2 Plus. It's a great little device. I really like it. Most people have a card in their PC to do the capturing, but I like the external one. It has the capability, in fact it's actually sort of made for gamers, and it has the capability to record games onto a little SD card, but I don't use it for that. I just use it as a straight through device to capture HDMI and output it on the USB port. And over here you see that's the one of the electronic HDMI switches. There's another one behind it that you can't see. So you can also see my analog oscilloscope here, which comes in handy sometimes when I use a curve tracer and I like the XY display on that one, because unlike the digital oscilloscope, the digital oscilloscope just takes little points. It measures points, and that's why they have a rating like the Regal there has 8 giga samples per second or something like that. But with a analog oscilloscope, of course, the sampling is, well, you could say that it is infinite, because it just responds. It doesn't do sampling, it just responds to the voltage of the signal. It has an analog amplifier which makes the beam in the CRT move. So I get much better results from that. It's also very simple to use, actually, much simpler in some ways than the digital oscilloscopes, because the digital oscilloscopes have so many features, you got to actually learn it after a time. But in any case, it's only 30 megahertz bandwidth, and of course it does not have the single trace capability. And on a digital oscilloscope, if you got an event that doesn't occur regularly but might only occur once every now and then, you can set a trigger on it, do the single, and then you can analyze the waveform on the screen on the oscilloscope and so on. So you really need both. I feel I need both. So now the oscilloscope that I am actually retiring is the one over here. That is the Siglant. That is also a digital oscilloscope, but I've kind of outgrown it. It only has 2 channels, and well, the triggering on it is more rudimentary, and sometimes I can't trigger on something that I want to trigger on. So that's why I bought the one of the reasons I bought the Regal oscilloscope. Regal oscilloscope has a little web server built in, and you can actually connect to it on its local IP address, and you can actually see the waveforms and so on, but the screen gets updated slowly, maybe once a second or something. So if you've got a fast changing waveform, then it is not much good. But the one thing that is useful about it is that you can actually control the microscope through here. Yeah, I can click zoom over here, and then it'll go into zoom mode, and so on and so on. And I'm currently in web control, and it has a few other things over here. Now, one of the reasons I bought this oscilloscope is because if I go to here, you'll see it comes with all the features installed. It came with a MSO5000 BND bundle, so everything is enabled in it. Originally, when they released this microscope, I think it was like 2017, maybe 2017 when they first came out. I suspect you would have had to pay maybe $1,000 or more for these features. The interesting thing is nowadays is that they create these oscilloscopes. Regal does anyway. It is already actually a 350 megahertz oscilloscope. It has 4 channels, but you can buy the they will sell it as a 70 megahertz for $909, but you can get the 4, because they're on sale right now. You can get the 4-channel one for cheaper than that, $799, but it's 70 megahertz, and then you can buy a license to upgrade it to 100 or 200 or 350. So the one I got is this one here, and it's like $600, $200 or $700 cheaper than normal, and it included that bundle, which of course wouldn't have been included normally. This is that free bundle option, and it includes all the features that it is capable of doing. So I thought this was a good deal for this kind of oscilloscope, so therefore I had to buy it. And as I said, another thing that I can do with it, I can pick up the HDMI output on it, which is much more useful because it actually is actually a little bit clearer than the screen on the oscilloscope itself. So it's actually it's bigger. I can actually look at it, but the good thing is that I can record it using OBS Studio, as you can see. And another thing that I like about it is that I've plugged in a mouse to the oscilloscope, and it has a touch screen as well, but you can actually use the mouse, to turn things on and off. And like I could bring in another channel. Of course, there are buttons on the oscilloscope itself that do the same thing as well. So you have 3 choices. You can touch the button, you can touch the screen, or you can actually use the mouse. And of course, you can use that web control thing as well. And there is software that you can install, but I haven't installed that yet. Ultravision or something like that, looks like, and then you control through the Skippy interface or whatever they call it. So that's one of the reasons I got the oscilloscope. It has the features that I need. It has a great number of triggers. Yeah, so on the trigger menu here, you have edge, pulse, slope, video, pattern, duration, timeout, runt, window, delay, setup and hold, nth edge, RS-232, I2C, SPI, CAN, FlexLay, RIN, I2S, and some sort of military standard arrow they call it. I don't know exactly what that is. And which is one of the things that I wanted. I wanted to get the enhanced triggers that the little Siglent scope doesn't have. And it also has a neat little menu here that you can get to as a quick way to get to things, because sometimes you might not remember which button to push on the oscilloscope to get to a certain menu that might be buried. And like for cursors, counter is what I've got up right now, shows you the frequency. It also has a DVM. You can use it to measure voltages and stuff, and so on. Fast Fourier capability, and it works pretty well, so you can use it as a little spectrum analyzer. Bode plots is one of the things that I wanted. I recently made a little preamp for my microphone, and I'm planning to use the Bode plot on it to see the frequency response on it, see if I need to make any changes to it, and so on. Let me change cameras again. I also wanted to show that with this remote control here, I can actually switch over. I just use the remote control. See, that's my microscope, and as you can see, it has a pretty nice depth of field now. Before, I was having problems with glare and I couldn't see things properly, and I'll show you how I fixed that. So what I have done is I have put these filters that I got from the I cut out 2 circles like a donut, and I put it underneath this ring light over here. And normally, without those filters on there, the ring light is really glary, and it's like you don't have a depth of field on the when you're soldering these little microelectronics. It was really unpleasant. And I've got some other microphones, and they behave the same way. But now that I have put this filter on there, I think it comes out really pretty nice. This is my little pointer. This stuff is under the microscope, and I think that I'm really happy about that. It didn't cost me anything, and it works really well. I've seen a video of some guy doing this kind of thing. He got polarizing filters, and he made up a 3D printed something with lights in it and everything. But I think this works even better. And what I've used is, I just some stuff that I had laying around from that old TV. So what I did was, with the microscope, I pulled apart an old TV, LED TV lately. Somebody gave me, and I was wondering if I could fix it, but I found out that some of the LEDs were burnt out, and it was a cheap TV, and the power supply for the LEDs had failed, so I decided that it wasn't worth fixing. But in those LED TVs, there are filters, and these are kind of interesting. They are not actually polarized filters, but if you look at them in one direction, they seem to be completely transparent. If you turn them over, they are not as transparent. And on the one side, there seems to be some sort of metallic sheen to it. I think I can see little dots, very small little dots on it or something, like a pattern. I don't know how that works. And there's two of them, and I found that the way that they're in the TV, if you put the two shiny sides together and with a 45-degree angle, then if you take a light source, let me turn it down a bit because it's a bit, hang on, a bit bright for the camera. You see the light going to there. It is actually causing the whole thing to glow. It diffuses the light in a particular way that stops the glare. If you put that underneath the ring light on the microscope. So this is actually the center of it, but I cut out a circle around this like a donut, and I put that underneath the ring light, and it has been working really well. I can see much better now. There's no glare hardly, and it's really interesting stuff. This, as I said, um, if you got this in the wrong direction, a little bit, the camera does not do a good job on showing this. But to me, like right now, I can see the lights to it. It's not diffusing properly. But if I put it the right way around, the whole thing is diffused. So in any case, that is what I have come up with. Okay, so that's all I've got. We're looking forward to doing some new projects soon. I've got some other things on order that I'm waiting for. Another curve tracer, which we want to have a look at, see if we can use that for anything useful. Tracing the circuits and components and so on. We'll find out about that when I get it. I also have some video that I want to post about that little pocket oscilloscope that I got. I've been using it and I got some updates on that. And if you like, give me some ideas from projects you would like to see to work on with the equipment that I have, and you can do that by putting it in the comments and subscribing and liking and all that kind of thing that you can do on videos. I hope that my videos will start to get better soon now that I got some new equipment, but I'm looking for some project ideas. I've got a whole bunch of microcontrollers, ST microcontrollers and SC32 and ESP32s and all that kind of stuff, so we'll be looking into that as well. Anyway, until next time.